Hello, everyone. My name is Leela Rhodes, and I'll be your moderator today. Thank you so much for joining us here at Netcom Learning, a market leader in promoting lifelong learning, training, and talent development solutions. We are very excited to host today's webinar, Microsoft Azure Master Class Instructor-led Virtual Section. And presenting today's topic is Vishal Nigam. Vishal is an experienced corporate trainer who has over 10 years of experience in various technologies. He has delivered more than 3,000 corporate training batches on different technologies. His skills include AI, ML, blockchain, RPA, Python, Golang, DevOps, cloud computing, and much more. And Vishal has over 7 years of experience in blockchain exclusively. He has built various products on blockchain and has trained more than 5,000 participants globally. He is also a global speaker, so we're really lucky to have him with us. Please bear in mind that this is just an overview of a very robust topic, and we do offer a collection of technical and business courses that can be tailored towards your specific requirements. If you're interested in a further discussion about any of those, you can make an appointment with our learning consultants through our website at www.netcomlearning.com. Netcom Learning helps customers build innovative learning organizations by achieving a smarter workforce, adopting change, driving growth, and we do this with a broad catalog of offerings, developing customized learning plans, and our global delivery capabilities. Since 1998, we have been empowering organizations with our managed learning services to help them reach optimal performance results and address challenges. We have 9 practice areas in which we specialize, and they encompass people, process, and technology training. And today's presentation is from the cloud practice area. Netcom Learning offers a comprehensive training portfolio for cloud courses, and our upcoming classes include various training on AI 900, AZ 900, AZ 104, DP 900, and many more. And private training to teams is also available, and those learning plans can also be customized to the specific needs of each audience. You can also access a variety of cloud marketing assets, such as the free on-demand training and blogs, by clicking on the available webinar handout. And these offerings can also be found with a simple search on our website at www.netcomlearning.com. An ebook is also available as part of the handouts for all attendees. In this event, we will get an overview of cloud computing with a special focus on Microsoft Azure cloud services and capabilities. And the event will not only talk about core Azure concepts, but also the management tools and core solutions on Azure. And now I'm going to go ahead and pass the time over to Vishal. Thank you so much for joining us, Vishal.
All right, thank you very much, Leland. Good morning, everyone, and welcome to this beautiful webinar on Azure Masterclass. Now, the reason we call it Azure Masterclass because this is the webinar which is going to give you some insights across the Azure ecosystem. And this is Vishal Nigam. Thank you very much for introducing me, Leela. And we are going to get started. Now, first thing first, in this webinar, I'm going to brief you down some of the beautiful concepts on how the cloud computing operates and some of the brief services that Azure has to offer. And that's going to be the objective behind the scene in this journey. So let's get started eventually. Now, the first thing first, when we kind of go into this part, and if you see there's a kind of an agenda there, so we'll talk about that. But the first thing first, what we are trying to learn is cloud. Right. The question would be, what is cloud service? So as the slide suggests, cloud computing is nothing but the delivery of computing services, whether it's server, whether it's storage, databases, networking, software, pretty much anything that you would use on the prem. Now you have an opportunity to use it over the internet. That means you don't have to worry about anymore in terms of the cost. There is no cost you have to worry about this. There is no upfront investment from you in terms of the infrastructure, which again makes the life a lot more easy. So imagine a situation of cloud computing. Now, the way I say it, cloud computing is the on-demand delivery of the IT resources over the internet. That means if I want to launch a virtual machine, I don't have to go and get a server of myself, that like a physical server, then install some OS, and then probably have some hypervisor, and then probably get a VM running. That means the management of this entire process is what I've been doing, because at the end, this is what I wanted. So what cloud computing does to you says that, what, I'm going to take care of this entire infrastructure for you. That means the IT infrastructure that you have in there, and you can access my resources on demand eventually and pay as you go. What do you mean by that? And if I want a VM, all I have to go to Azure in this case, which is our cloud provider, ask Azure that, hey, Azure, I want to have a virtual machine where I want 2 vCPU and also I want 2 GB of RAM. And Azure will say, sure. Why don't you go ahead and opt a compute services from me, and I will give this you for an hourly cost. So you will like say, wow, absolutely great, because I probably just need the server for 6 hours. I don't want to invest thousands of dollars just to use a machine for 6 hours. So cloud computing, kind of becomes a model where you pay for the clouds that you use, and that will eventually help you to do what? That will help you to lower your operating costs eventually and run your infrastructure more efficiently, scale your business needs as required. And the company providing these services, they are going to be called as what we call as the cloud provider. And there are a lot of vendors which does their job for us. For example, we've got Azure, which is the Microsoft offering, and we've got AWS and Amazon offering, and GCP, that's a Google Cloud offering. And the cloud provider, in this case, that is Azure for us, that's going to be responsible for the physical hardware required to execute your work, in addition to keeping it up to the date. And every business is, it's unique, right? It has different needs there. And to meet those needs, cloud computing providers, they offers you a wide range of services. And typically, those services are going to be into a domain like compute power. So we are going to get compute as a service, like we can get these Linux servers, for example, or we have services like storage, eventually in which we can store our files or maybe the databases, or we have services in the domain of networking where we can have maybe a secure connections to our network infrastructure on the cloud there, or maybe we have a lot of analytics services, let's say, for example, where we can get some performance data about how my application is um, uh, um, um, behaving eventually. So, cloud kind of offers you a lot of these eventuality in these way. And to do this, if you actually go to Azure, just to, oops, not this one, just search for the Azure itself. Oops. And if you just go on Azure and just look at Azure as this is the platform we're talking about, imagine what is Azure offering you. I mean, if you just click on the product, look at the offerings Azure gives you, starting from AI, machine learning to analytics, to compute, containers, databases, DevOps, identity, integration, media. There are so many services that you do. So imagine, let's say, if you want to only get a virtual machine, Azure gives you a service called as the virtual machine. One of the core foundational services that Azure offers you. You get Azure SQL, which is a database service. You get Cosmos DB, again, a NoSQL database. You got AKS, which is a Kubernetes managed service. You got cognitive service in terms of AI. You got app services in terms of platform offering. You got the quantum services. You got functions, serverless computing. You got containers, databases, DevOps, dev tools there. You can see a lot of tools that you use. I'm sure a lot of you have heard about Visual Studio. They have a dev tool offering for the cloud itself there. You've got hybrid solution there. You've got identity solution, integration solution. There's IoT. There is media solution. Imagine that you want to host a lot of content. Let's say you want to build a Netflix of your own tomorrow, and you want a solution, a service which can help you to build that infrastructure. It will provide you services in the case of media services. You got migration services. How do you migrate from on-the-prem to from to Azure itself? Mixed reality, AR and VR. I'm sure everyone is aware about this metaverse that's happening in the world right now. That's called as mixed reality, where you have got augmented reality and got the virtual reality, AR and VR. You have a complete solution for that. You don't have to really build stuff up your own. You just can leverage services there. So imagine what Azure has to offer in different domain, networking, security, storage, web, virtual desktop. You've got so many service offers. Imagine that if you have to build these things all by yourself. So that if we kind of talk about these eventualities in this way, you can imagine that the goal of cloud computing, I will tell you, I would primarily define cloud under four domain. That means there are four fundamental services that any cloud will be about. It's going to be about compute plus storage plus networking and plus the database. So if you combine these four, that will be the fundamental of pretty much any application that is running across the internet. And if I talk about compute power, so let's say, think about this way: when you send an email or book a reservation on the internet or pay a bill online or even take this Microsoft, course, we are interacting with some cloud-based server that are processing each request and returning a response. I'm talking to you. We are doing this webinar over the GoToMeeting. They are hosted somewhere. That means there is some server somewhere on the internet which is processing this request for us in eventuality. And as a consumer, we all are dependent on these computing services provided by different cloud providers that kind of makes up the internet. So when you build a solution using cloud computing, you can choose how you want the work to be done based on your resources and needs. For example, if you want to have more control and responsibility over maintenance, you could create a virtual machine. And what is VM basically? A VM is an emulation of a computer, just like your desktop or laptop you're using now. Each VM includes an operating system and hardware that appears to the user like a physical computer running Windows or Linux. And you can install whatever software you need to do the task you want to run on the cloud. And the difference is that you don't have to buy any of the hardware inside the OS. The cloud provider runs your virtual machine on a physical server in one of the data center there, and after sharing that server with that physical something. So VMs aren't the only computing choices that are there, but there are the two popular options that I would say that virtual machines ecosystem offers you. That is called as container. I'm sure a lot of you must have heard about containers there, which gives you a more consistent, more isolated environment for running application. And what eventually happened that there are pretty much like you can say similar to the virtual machine. What they don't do there, except what happened there, they don't require any kind of operating. So you have a containers in this I call a C1, in which I am not dependent on an operating system. My application, it's all binaries, the dependencies, the libraries, along with the OS. It is all packaged into an image, and an image is going to run. And we're going to run an instance of an image called as container. And there are a lot of different approaches there, which allows the containers to start in just seconds, because there is no OS that I have to boot in there or initialize, and you only need the app to launch in there. And there's an open source project called as Docker. I'm sure a lot of you must have heard about something called as Docker there. Now, Docker is one of the most popular containerization platform. That is a leading platform for managing container. Now, Docker containers provide you an efficient and a lightweight approach to application deployment, because they allow different components of the application to be deployed independently into different containers. And then the multiple containers can be run on a single machine, and containers can be moved between machines, and the portability of containers kind of makes it easy for applications to deploy in multiple environments. Either it's on the prem on the clouds there, so that you don't have to really make any change to the application. So in order for me to get compute, you can see even what eventually these containers are doing. They are giving a way to have compute, because if I'm running an application, that means application is going to need some kind of CPU and RAM and storage, for example. And what these containers are giving you a way to manage this, but in a more portable way. And the thing which can do this for you is Docker. Now imagine if I have to manage two containers, it's fine. What if I have to manage 2 million containers? That's going to be hard to do it, because to manage that kind of infrastructure is a great job. So Azure says that don't worry about that. I have got a service for you which can eventually help you to get these containers. So if you go to the Azure products offering and you see the compute section, what you will see that we are going to have the container services there. There we go. And you can see we have got the container instances as a service, where you don't have to worry about the Docker, its installation, anything behind the case. All you have to do is just run the container. So you can say the run the containers without managing the server. So I don't have to really worry about any of those objectives, and that's the beauty behind the container. Then apart from the container, let's say you are absolutely focused on building your application. You don't want to look at any single option where you have to manage a server for even in this virtual environment, even for a moment. You don't have to really worry about that. You're like, you know what, I'm not really interested in doing those objectives. Now, if you're not interested in doing that, we are living in the world what we call as the serverless computing. The world that we're living, it's serverless. Now, what is serverless? Eventually, if you look at the slide here, serverless computing is where you want to run your application, but the beauty behind the serverless, you're not going to manage your application infrastructure anymore. That means all I have to do is give the service, whichever is we calling as a serverless computing, ask the service that, hey, you know what, this is my code and I want you to go ahead and run my application. And that service is going to do the job for you. So the core idea is that your application is broken into what we call as these separate functions, and eventually they are run when triggered by some action. And this is ideal for a lot of automated tasks. For example, you can build a serverless process that automatically sends an email confirmation after a consumer makes an online purchase. And the serverless model kind of differs from VMs and containers in that you only pay for the processing time used by each function as it executes. And these VMs and containers, they are charged when they are only running. So the beautiful part about the serverless, you are only going to get charged when this function is going to run. Unlike a virtual machine, which is going to run 24/7, whether that machine is used 100% throughout the time or not, you are going to get billed for that. But with functions, you are only going to get charged when this function is going to be called or triggered there. So VMs and containers, they are charged while they're running, even if the application on them are idle. When this architecture doesn't really work for every app, but when the app logic can be separated independent units, you can test them separately, update them separately, and launch them in microseconds. And making this approach, you can say, the fastest option for deployment. And in a simplistic manner, this is how you would kind of behave that. So if I have to kind of give you a more clear perspective, imagine this way. I'll try to draw some things. So don't worry, don't take my drawing so serious. Let's say this is my um, physical hardware, and I'm using this call as a virtual. This is my virtual machine. So virtual machine, you have a physical hardware, then you have the host operating system, and on top of that, you have a hypervisor. Let's say, for example, we have a VMware, we call it a hypervisor, and then you have a VM1, and you may have a VM2 and a more VMs, and where you have your applications. Let's say behind the process, you've got the guest OS, maybe that's a Linux OS, for example, and then you may have this virtual hardware that is being given by you, this VMware. And same thing you have here, you have got your app here, and you maybe this time you have a Windows OS, and then you have this virtual hardware. That's the way your virtual machines operate there. That means you have to manage all these things. If you go to containers, life become a lot more easy. So you will have the infrastructure in this way. That means you will have the host operating system there for you eventually. You will have this physical hardware for you eventually, and then what you will have is a container engine, which is in this case, remember, that was Docker. So you got this container engine for you, and then you will run containers C1, C2, C3, as many applications you want to run on one single virtual machine. Now this engine can run on any virtual machine. So instead of me, let's say in this case there were two VM for running two applications, now I can have one VM and I can run 10 different applications. And if I go to completely serverless model, that's a different model. In the serverless, what happens, you have the same option that you have the physical hardware again, you have got the host operating system, but now there is this instead of a container engine, you will have a serverless runtime engine here, and then you can run as many functions. I will call as F1, F2, F3, F4. These are functions, and each function is going to do something for me. So you can say in this case, this is my serverless offering here. So if you look at these kind of examples, eventually to get the job done, this kind of becomes a segment for you. This kind of make things more segmented for you. So I have one environment there. I have to manage a lot of things. Then this is, I would say, as compared to then, this is a more of like a less of the management of the hardware. And this is, you can say, pretty much 0% management. And that's the difference. Now imagine if you have to build the application, you have an opportunity to figure out these models and kind of get the job done. And that's how these containers kind of operate and kind of work in direction. Now, this is only the part where we have the compute, right? Now imagine that when you are having this kind of compute, what is that next thing you would require in order to make it happen? In order to for you to get this done, you would also need storage, right? So there was compute and there was storage there. And most of the devices and application, they read or write the data. And think about, let's say, if I'm buying a movie ticket online or looking at the price of an online item, for example, or taking a picture, in that case, whatever that person could be, or sending an email, or leaving a voicemail. In all these cases, data is either read, maybe I'm looking for a price, or it's written, probably taking a picture. So the type of the data, how it's stored, can be different in each of the cases. So cloud providers, they typically offer services which can handle all of these types of data. For example, if you wanted to store text or a movie clip, you could use a file or disk, right? Or if you had a set of relationship like an address book, you could take a more structured approach and like use like a database, for example. And the advantage of using the cloud-based data storage is you can scale to meet your needs. If you find that you need more space to store your movie clips, you can pay a little more and add to your available space. And in some cases, the storage can even expand and contract automatically. So you pay for exactly what you need at any given point in time. And every business, I believe, has different needs and requirements, and cloud computing is really flexible. It is cost efficient, and the goal of the cloud computing is to really make running a business easier and more efficient. Whether it's a small startup, could be a large enterprise, it's just to make our life more easy. That means when we use cloud computing, we gotta have a lot of benefits there. And cloud services is, I believe, is a big shift from this traditional way business think about IT resources. That before, that cloud computing is the on-demand delivery of the IT resources over the internet. And these cloud services, they have the characteristics and considerations, and some of them I've written here. So if you talk about high availability, now high availability is one of the benefits of cloud. Why? Because it's an ability to keep the services up and running for a long period of time with very little downtime, depending on these services in question there. If you talk about scalability, that means that's an ability to increase or decrease the resources for any given workload. And you can add additional resources to service a workload, like call it scaling out, or add additional capabilities to manage and increase in demand to the existing resources, like scaling up. And that scalability doesn't have to be done automatically, so you can be scalable. You can think about elasticity, which is about an ability to automatically or dynamically increase or decrease resources as needed. And elastic resources, they match the current needs, and the resources are added or removed automatically so that we can meet these future needs when it's needed. And from the most advantages, geographic location, to be precise there. And there's a distinction between scalability and elasticity, is that elasticity should be done automatically. Then we're talking about agility. You got to be agile. You got to be able to react quickly. The cloud services can allocate and deallocate resources very quickly. They are provided on demand via self-service. So the vast amount of cloud computing resources can be provisioned in minutes. There is no manual part of doing that part here. There's no manual intervention in provisioning or deprovisioning a service. That's why the agility is there. We can think about fault tolerance as a behavior also. Now, the fault tolerance is where you want to think about having an ability to remain up and running even something goes crazy. Imagine that something goes where you've got your data centers to be burned out and you still want to be up in there That's where the point is here. So the ability to remain up and running, even in the event of the component or service no longer functioning. So typically, redundancy is really built into cloud services architecture. So if one of the component really fails, a backup component takes its place there. And there's a lot of automation. I would say there are services that are being readily available there. And things that I will also add apart from this is with cloud, I kind of get what we define as the global reach. That means the ability for me to reach audiences around the globe was not possible or feasible, I would say, a decade back. Imagine Netflix, for example, as an example, is serving content to the user globally. That means they gotta have these mechanism, that infrastructure, which are going to present in the local market, or they should have to have infrastructure that can provide the content to these global audience. So cloud services, because they have presence in the various regions across the globe, which you can access, kind of give you a presence in those regions, even though you may not have an infrastructure in the region. So global reach could be one of the part here. I would also say, because there's global reach, there is latency factor also. So if, let's say, your customers are experiencing slowness with a particular cloud service, they're set to be experiencing latency. Imagine, let's say, if I'm in the New York and there is a and my servers are hosted in New York, and there are a customer who was trying to access some content from Singapore, they may face some latency. Why? Because they have been exposing and experiencing accessing it over the internet from a very far location. That means even though these modern fiber optics are fast enough, it can still take some time for services to react to customer actions, if the services is not local to the customer. And cloud services, they have an ability to deploy resources in data centers around the globe, therefore addressing these customer issues there. And then, because of doing this process, you have an opportunity to predict your cost there, because that's an ability you want to do when you're on the cloud there. You want to be able to predict what cost you will incur for a particular cloud service. If I'm using a compute engine, how much do I pay? If I'm using a specific service, how much I'm going to pay? It's not like you're blind in that situation there. So costs for these individual services, they're made available, and there are tools which are provided to allow you predict what costs are or a service will incur there. It's not like you will be paying anything on your side of it. So if you see this, and this is where thing happens. So let's say, for example, I want to be able to use the virtual machine service. That's it. Let's start with very simple. Now I can go to the pricing tab here, and I can see how much price I am going to be able to give in here. So in this case, we are going to be looking at this. So we can look at this pricing calculator that's given by Azure, and look at the virtual machines as an option there. And in this pricing calculator, I will get to know whether cloud computing is going to be cheap for me as compared to my current data center or not. So let's say if I'm using one of the regions, I will talk about what regions are very soon. But let's say, as I remember, I spoke about the global presence. Let's say I'm in one of the regions there Azure has availability, maybe central United States, and I want a Windows operating system here, and they are tiered, but let's I want to go with the basic plan there, and I want to be able to use an instance. Now, instance mean that how much RAM and the storage and the CPU on there, and how many virtual machines I want for how many hours. You can see this kind of gives you, and if you can give the option, you will get to see that in this case, for using this, the tentative monthly cost is going to be about $13. And that is really cheap, right? So imagine that if you know upfront how much you're going to get charged, your life becomes a lot more easy. And that's one of the benefits of cloud computing. One of the important things that needs to happen in the cloud computing is that, um, we have more productivity. Now, productivity is like, if you have an on-site data center, that would typically require a lot of hardware setup. Otherwise, we think racking and stacking, for example, or there is software patching, or there are some of the time-consuming IT management chores in there. And cloud computing kind of eliminates the need for a lot of these tasks. So teams can really spend time on achieving more important business goals there. And eventually, one of the important things that I want to quickly address at the last in terms of benefits is security. Now, cloud providers, they give you a broad if you talk about security, that's a very important thing. Now, cloud providers give you a broad set of policies and technologies and controls and expert technology skills that can provide you a better security than most organizations can otherwise achieve there. And the result is strengthen the security, which helps you to protect the data, the app, the infrastructure from these potential threats there. And there are a lot of benefits when you move to the cloud. And let's say if you're a company who wants all these capabilities, I bet your application could really get a lot of benefits from there. So if I talk about, let's say, one of the, and I'll tell you simple examples. Let me tell you. So apart from me in a training, I have a couple of great startups, I think. And one of my recent product that's kind of running here, I'll show you. It's a fitness tech product. Look at this product. So we call this product as WTF. And eventually what happens there that this product is completely hosted on the cloud. We are, I would say, think about us like an Uber for gyms in a most simplest extent. Now, we wanted to build this product. We wanted to create the product. We wanted to focus on the product. So what we realized, we leveraged cloud computing behind the scene. And for that perspective, we hosted our entire application, everything that is required for that. And we were able to create infrastructure that was highly available, because high availability is a must. At WTF, we're going to make money and keep our customers or users happy when they can get to my product. When my app goes down, or let's say my membership system or other features can't talk with each other, it is a critical situation. So high availability is an important part. Scalability and elasticity is something we at WTF have wished forever there. I mean, I have been a part of the journey where we have purchased thousands of servers, had to manually set each one up and manage them, and then many of them kind of they were kind of ideal, waiting for the users to relog in, and they were using power, they were using heating and cooling, and they had to be maintained. And then there were a rush of people logging in during seasonal part of the year, and things really kind of bogged down. And then there was a disaster recovery situation that would be great to have. I mean, I remember, so I'll tell you, before all this, I used to work with Cisco, and in Cisco, I used to assist a lot of customer, and all of them, they were running these on-prem backup system and then transporting the backup offsite for storage, which was a time-consuming and a costly affair. And I will tell you, was a really slow process to restore if we have an issue. So backing up the customer order and history and data the moment it is entered is an absolute must. So and those customers can really survive if they really can't get your customer information. So all of these things really was important and kind of given as a perspective. When we get into a cloud, one of the things we can do. So imagine, we to do this, build this application that I have got is called WTF. What we have done, we have got multiple services, to tie up together. That means if I had to do them all by myself, it would have been a costly affair. That means what I wanted to address something that in cloud computing terms we call as economies of scale. Now, what really happens when you say economies of scale? The concept of economies of scale is an ability for you to reduce the cost, gain the efficiency when operating at a larger scale in comparison, I would say, to an operating at a very smaller scale. So when you operate in bulk, you can basically save the cost. So cloud providers, let's say, for example, Microsoft or Amazon, they're large businesses, and they're able to leverage the benefits of economies of scale and then pass on those benefits on to their customer. This is apparent to the end users in a number of ways, one of which is an ability to really acquire the hardware at a lower cost than if a single user or a smaller business were purchasing that. So that is an important factor there. So think about storage cost, for example. So in my example, I'll tell you this example we're using. So what we do here is that we kind of leverage the processor, and the storage costs have decreased significantly over the last decade, because of the part of the cloud provider. So if you have to store, I have to store a lot of data from my customer. Imagine I had to buy so many storage devices to do that, and I would be burning a lot of money in just doing the storage part of it and running the servers. Now I am able to do this entire stuff at 1/100th of the cost and focusing more on my application instead of really figuring out the infrastructure there. So we are able to use that extra storage that cloud gives me for more efficiently and pass on those benefits to the end users in the form of using the lower price. And that is something else. So eventually, what we're trying to do here, and you can imagine by this time that this is a concept of the capex versus the OPEX. I hope everyone knows about that. Is capital expense versus the operations. So what we're able to do is we are able to uh, figure this part in the capex versus the apex domain, and that is an extremely important aspect. Now, I would say before cloud computing, the previous startup companies, they needed to acquire a physical premises and infrastructure to start their businesses and begin trading. And large amounts of money were needed to really get a new business up and running or to grow an existing company. And they would have to buy new data centers or new servers to allow them build out these new services, which they could deliver to their customer. And that is no longer the case there. Today, organizations can sign up for a service from a cloud provider to get up and running, and this enables them to begin selling or providing services to their customers more quickly without the need for significant upfront costs. And basically these two are to help you. So either you have a capex, which is a capital expenditure, which is about spending of the money on the physical infrastructure upfront and then deducting that expense from your tax bill over time. So capex is like an upfront cost which has a value that reduces over the time. And OPEX, which is an operational expenditure, is about spending the money on the services or products now and being billed for them now, and then you can deduct this expense from your tax bill in the same year. So there is no upfront cost you pay for a service or a product you use there. So it's a very simple, a typical, example for an on-prem data center will be, so let's say if I have to think about a capex cost, if I'm running everything on my own, there will be storage cost. I mean, you have to think about, sorry, a server cost, let's say. Think about all the hardware components, the cost of how to support them. So when you purchase servers, you have to make sure to design fault tolerance, redundancy. So you have to cluster a lot of servers. You've got to have redundant power supplies, and you have to have these UPS, which is uninterruptible power supplies. When a server needs to be replaced or added to a data center, you need to pay for the computer, which can affect your immediate cash flow because you must pay for the servers upfront. There is storage cost there, which is about including all the storage hardware components and the cost supporting that. And based on the application and the level of fault tolerance, centralized storage can be expensive. For a large organization, you could create these tiers of storages where more expensive fault tolerant storage is used for critical applications. But there is a cost. There is the networking cost. There will be a backup and archival cost, and there is a data center infrastructure cost. I mean, these are the costs for constructing and building equipment, as well as future renovations and remodeling costs that may arise as demand growth, and maybe technical personal costs, that people who will be managing these resources. So these are the costs you may have there, and there's no other way of running your own data center. But imagine if it's an OPEX model. So with cloud computing, a lot of these costs associated with an on-prem data center, they are shifted to the service provider. So instead of thinking about physical hardware and data center costs, cloud computing has a different set of costs. And for the simple accounting purpose, you can say all these costs are operational expenses. And leasing the software and customized feature using a pay-per-use model requires actively managing your subscriptions to ensure that users did not really misuse the service and that provision accounts are being utilized and not wasted. As soon as the provider provision the resources, which is Azure, your billing starts. So it is your responsibility then to deprovision the resources when they are not in use so that you can minimize the cost. Or cloud computing can really, you bill in various ways. So you can get billed based on number of CPUs, number of usage hours there. Maybe you can get based on bill of whether you are reserving a resource or anything in that case. So there are a different models. And then, both of the models have their benefits. If I, let's say, talk about the benefits of capex, so with capex, you plan your expenses at the start of the project, or you kind of have a budget period, and your costs are fixed, meaning you know exactly how much is being spent there. And I will say this is appealing when you need to predict the expenses before a project starts due to a limited budget. And in terms of Apex, your demand and growth can be unpredictable. So, for example, I was telling about this in my app here, right? So I don't really know how many users I'm gonna have in next, let's say, 3 months. I don't know. My demand, my growth is unpredictable, and because of that unpredictability, it's a challenge for a capex model to kind of scale that. Because with the opex model, I want to try maybe a new product or services, and I don't need to invest in equipment, so I can pay as much as little. I can start from a very small machine. I can grow as one things forward. So you can imagine that it's more of like a consumption based model. Cloud service providers operate on a consumption based model, which means that as myself as an end user, I have to only pay for the resources that I'm using. So whatever I use, I will pay for. And the consumption model really bring a lot of benefits. Number one, I would say there is no upfront cost. I can just go ahead, even with just $10, I can start having a full-fledged website running with my scenarios. There's no need to purchase and manage this costly infrastructure that may or may not use its fullest. There's an ability to pay for additional resources when they are needed. And there's ability to, stop paying for resources which are no longer required. So which kind of allows for a better cost prediction. So prices for these individual resources and these services, they are provided to you, so you can predict how much you will spend in a given bill. So you have a complete control in doing that process. Now, when I do this process, we typically have three kind of cloud models. So we have a public cloud model, we have a private cloud model, we have, you can say, on a hybrid cloud model. So if we talk about these set of models, compare these set of models eventually. So let's say if I talk about, let's say nothing else. Let's talk about a public cloud. Now, a public cloud is the one that is owned by the cloud service provider or the hosting provider. It gives you resources and services to multiple organizations and users who can connect to a cloud service via some secure network connection, maybe with the internet there. So all these public cloud models, they have an ownership. When I say ownership, it's about the ownership of the resources that an organization or end user is going to use there. Maybe the virtual machine infrastructure there. I mean, or think about storage or processing power. So basically, in a public cloud model, those resources that do not belong to you as an individual user or an organization. So they do not belong to an organization that is utilizing them, but rather they are going to be owned and operated by a third party. That could be my cloud service provider, could be Azure then. Public cloud models may take resources and then they kind of make the resource available to multiple users there. And public access allows the public, that means you and me, to be able to access whatever services are going to use in there. And then availability is the most common cloud type deployment model there. And with a public cloud, in a simple way, there is no local hardware for you to manage or keep up to date. Everything runs on the cloud provider's hardware. In some cases, cloud users can save additional cost by just sharing a computing resource with other cloud users. And a very simple use case scenario would be to deploy a web application or maybe a blog website on hardware and resources which are owned by a cloud provider. And using a public cloud in this scenario kind of allows users to get their website and blogs up and running quickly, and then focus on maintaining the site without having to worry about purchasing and managing and maintaining the hardware on which it runs. And Azure is a prime example of a public cloud. Let's say you are not comfortable with public cloud, so you can move to a private cloud model. Now, what is a private cloud model? Now, this cloud model is owned and operated by the organization itself that is going to consume the resources from that cloud. And they can create a cloud environment in their own data center, provide a self-service access to compute resources to users within their organization. And the organization remains the owner, entirely responsible for operations of the services they provide. So cloud, if I have a private cloud model, then the owner and the users of these services are same. So if I am using a cloud model, then I am the one responsible for the infrastructure, and I'm the one responsible for managing the resource. And you would think, okay, Vishal, if it's a private cloud, how do you run this? A simple service would be if you Google OpenStack, OpenStack is an open source cloud infrastructure. So you have your own servers, you want to manage them like a cloud model. You can use an OpenStack as service and go ahead and deploy your own private cloud, and everything is private to you. Your connections are private. They're already made over a typical private network there. You will not provide any access to public there. And in this case, the point is there, you're going to have a deep technical knowledge to really set up and manage and maintain this infrastructure there. So you have an opportunity to go with this route also. And you're like, you know what, it's okay. I can just go and deploy my own solution there. And then the last of the option, if I combine both public and private, I will call it a hybrid option where you combine both public and the private clouds. So now this kind of allows you to run your application in the most appropriate location. And basically what happened there, let's say there are certain use cases in which you are not allowed by the compliance of the local regulatory bodies to go and host your customer data into someone else's server that you don't control. And for that perspective, what would you do here is you will actually go ahead and kind of get the job done. So it is a very simple thing to get the job done. So you want to be able to have a control, and at the same time you want to be able to build systems around this process, and that is how a public versus private model operate. That means you don't have to worry about that. Can I use one? Can I use both? Or can I use either of them? You can use both of them based on the requirements. So you can control a part of the infrastructure. Let's say you want to control your data. You want to make sure that my data remains in my control at all point of time. You can store your data in on-the-prem location, and you can store and leverage the cloud provided services in terms of compute offering, and you can leverage that stuff. And whenever you want to read the data, you can just direct that application that is running on these virtual machines in the cloud to go on the prem and read that. So you have an opportunity to do this option. And imagine in the case of a public cloud, if I just talk about, let's say, Azure itself, look at this example, what's happening. I mean, public cloud is going to be one of the most common deployment model because right now the world we're living, you don't have really time and opportunity to really move in this direction. In that case, you have no local hardware to manage or keep up to date, and everything kind of runs on your cloud provider's hardware. In some cases, you can save additional cost by sharing compute resources with other cloud users, and businesses can use multiple cloud providers. So it's not like you're bound to a cloud provider. So there's no capex cost. You don't have to worry about it. Okay, if I have invested in a Dell's hardware, I can't really buy something else. I can use compute the way I want to use it. I don't have to worry about that, and I'm not really bound with anything. So there's no capex. You are agile there because your application can be made accessible quickly, and they can be deprovisioned whenever needed there. And the consumption is based on a pay as you go. So you are going to charge or get charged based on how much there. But then everything can't be good, right? There could be some disadvantages. Security is one of the things that you have to work exactly in the way the security is provided by the cloud. It's not like you can work in a model that kind of suits you. It has to be the way that cloud provider kind of operates it, and you have pretty much no role play when it comes in that direction. So that's again is going to be an important aspect when it comes to this journey or this model. So you have to be again um, careful about how this entire world things will operate there. And then compliances and ownership is also not here, but you have benefits of saving costs. So you have to make those differences in class. And when we say this Azure Master Class, this is where as an Azure architect down the line, you have to think about this. So if you go to, I'll tell you, if you go to a Azure certificate, now see what is the beautiful thing about this whole process. If you go to Azure certification and look at this spot here, that the list of how you want to go to Azure ecosystem, it's kind of based on the roles that I don't want to get started. Let's say if you all are starting into the cloud ecosystem, you can go and let's say take a fundamental class here, which is a certified fundamental class, and understand these ways of how do we really move in this model there. And you can have all these understanding on the concept there and how they operate there. So it's a very important piece for you to understand that it's a role-based cloud. So you want to be either a developer, you could either be a data engineer there, could be a DevOps engineer, could be an administrator, data scientist, AI, whatever you are, you can actually move and look for an offering. Okay, that what's the right path for me to move in the Azure ecosystem, and you can move them there. Why? Because that's a public cloud offering, and you want to be able to doing one specific task or job in that segment. So that kind of makes a lot of differences there eventually. And then obviously we have this private cloud, so you where you create your own environment there like this in your own data center, provide a self-service access to the compute resources to the user in your organization there, and that kind of gives you a simulation of a public cloud, but everything is still controlled and managed by you. So you can imagine that the life kind of becomes much more controlled, but you have a lot of work to do. So you got control, you got security, you got compliance, and then there is an upfront capex. You have to invest in the hardware. There is no agility because you are having a limited infrastructure only. You don't have unlimited compute, unlimited storage like the way Azure can provide it, because they've spent billions of dollars on infrastructure, and that infrastructure is shared with the rest of the world or their customer there. You are responsible for maintaining everything there. So that's an again extra cost. Apart from investing upfront in the capex, you have to ensure about the infrastructure maintenance there. If something goes down, you got to fix that. You are going to be part of that. So again, you get control, you get security, you get compliance there. You will be able to design things the way you want it there for a specific scenario, but then you have to have some design. So you can use a model. So one part is there, and these are the way you do this. Now, regardless of whichever model you use in the cloud, everything is dependent on three things. One is infrastructure as a service, you have platform as a service, or software as a service. That means either I'm using a public cloud or a private cloud or a hybrid, I will be leveraging a service in these matters. Now, if you just think about infrastructure as a service, that means I am going to use someone else's infrastructure. That means infrastructure service is where, you know, um, the most of the user management of the cloud service is required by the user. That means you as a user will be responsible for managing the operating system, the data, the application. So imagine a model where, in infrastructure as a service, what will happen there, that you've got this situation that you're on the cloud, your Azure is managing the storage for you. Oops. Then Azure is also managing the networking for you. Azure is also managing the compute for you. Now, what you have to deploy, you have to deploy your own VM here. Or let me put it this way. I will make a different color here. So I have to deploy my own VM. I have to manage my own operating system. Its path is there. I have to manage the runtime, my operating system, and my application. That means Azure is saying that, hey, I'm going to give you the infrastructure and I'm offering you this as a service. So you can go ahead and use my infrastructure that's given there, but then you will be responsible for managing these components for you. Or even if you're using an private cloud, your IDM will say that, hey guys, you know what, I'm giving you this infrastructure there, you can use it, but that you will be the one responsible for managing your VM, what VM you want. If you want a Linux VM, you want a Mac OS, you want a Windows VM, you want whatever you want, you decide that, you handle that OS, you handle the runtime, you handle the application, you handle the data and accessibility, and that's where we say this is infrastructure service. That means you manage a lot of components. Now, let's say we move from infrastructure as a service and move to platform as a service. Now, what happens in a platform as a service, that a lot of these components are going to be, so in platform service, what happens, Azure or any provider will say, okay, what, I will just manage the VM for you and the OS for you and the runtime for you. You just go ahead and manage your application and the data, and I will manage the rest of the things. You're like, okay, that's great. That means all you have to do is just probably tell the service that, hey, I want to run a server with 2 CPU and 2 RAM. The service is going to run that for you. In Azure, we have something called as app service, which does this job for you. It will do this scenario studies for you and will say, you know what, I will handle the show for you and get a run behind the scenes. So that's going to make a beautiful aspect around the process. And then, you can actually go into a completely SaaS model, and a SaaS is where you have an ability, your software is centrally hosted and managed for the end consumer. So it allows the users to connect and to use the cloud-based application. That means the whole point of the SaaS is it allows. Think about, like, say, let me if you've used Gmail, I'm sure a lot of you would have. That's a SaaS offering. If you have used Microsoft Office 365, a SaaS offering. SaaS is typically licensed through a monthly or annual subscription, and these solutions are there. So depending on the models are, so in the IS, you only have to worry about so everything. So in IS, as a provider, servers and storage, networking, and data center is managed by the provider. In the platform service, along with this, they manage the operating system and the any kind of dev tools or but the end of the SaaS, everything is managed by them. You just get an entire wholesale application and use it as you want it there. So you don't have to really worry about any of those objectives or process there. So in SaaS, you don't have any upfront costs. You pay for the subscription, typically a monthly or annual fee. And I'll tell you, this product I was showing you, this my app here, this WTF, it's a SaaS offering. Why? Because the gym, so basically what do we kind of digitalize a gym here? So gym doesn't have to go ahead and deploy their servers and build this application, everything. It is us managing this entire journey for them. They have to basically subscribe to our application and kind of be a part of the WTF family, and that's it. So SaaS, now their job is just to use the application and pay for different services around the scene. So that's where SaaS becomes one of the most lucrative model that kind of happens like this. So you can imagine that at all point of time, you have an opportunity, you have an ecosystem where you can build and get these system around this. So this becomes a very interesting, I would say, contribution. It becomes a very interesting proposition from the cloud to kind of move in this direction and say, you know what, let's leverage this. So this is a way of how you can say we can operate in this modalities, and from there, you can operate and build your systems. This becomes an easiest case. So if, let's say, if I have to create, and now I'm going to start showing you one small demo. So let's say I have a requirement, and the requirement is very simple, that I want to deploy a virtual machine. Now, imagine if you have to deploy a virtual machine, what happened that you need a service that can help you do that. So one of the services in Azure that is called as the computing service. Now, computing service is something that can help you deploy a virtual machine. At the most easiest sense, that what the service will do about you is to help you deploy machines. So if I talk about Azure compute services at the scene, and even before that, I'll talk about a couple of other things there. So when you have to look at this Azure, now Azure is spread, globally. Obviously, if it's globally spread, Azure will give you some opportunities to choose where you want to deploy your machine. And in order to do this, one of the things that Azure gives you, let me show you it on the slide itself. Not slide, let's say. So if you do Azure Infrastructure, if you look at this, yeah, in Azure Infrastructure, everything in Azure is going to be about yeah. So if you look at this, this is going to give me a better perspective of how Azure is spread globally. Let this load for a moment. It's a beautiful animation done of how Azure is spread globally there. Alrighty, fantastic. So as you can see, one of the things that this slide is talking about, that in Azure, one of the things that it says that it gives you a way to deploy resources. You are spread across different regions there. So if I skip the intro part of here, right, and explore the globe here, now look at this, what is happening here. Now in Azure, in a globally, these are what we call here as regions. So what happens? Azure is made up of data centers located around the globe, and these data centers, they are organized and made available to the end user by a region. Now, a region will be, let's say, if I click on Canada East, it's a region there. Now, what's a region? A region is a geographical area on the planet containing at least one, but potentially multiple data centers, which are in the close proximity and they're networked together with a low latency network. And Azure intelligently assigns and controls the resources within each region to ensure the workload, they are appropriately balanced. So think about, let's say, Canada East is a region, you click on the East US2 is a region, You click on Central US is a region, and kind of shows you how many when this it was open there, and the product in this region, and some of the compliance around this. Kind of shows you that perspective there. And Azure is available at this moment. If I look at this, what's the current number of regions? So we have to kind of look at this, because every day these regions are kind of including there. So if we look at this more three tour here, let's say, and this kind of shows, so these data centers, so all these regions that kind of happens there, you can see here, they give you the data centers, and these, you can see these are data centers. So every region is gonna be having the data centers. If we explore the globe here, yep, there we go. Fantastic. This is kind of changed there. So if you look at this, this is kind of the data of how many regions are there, and this combinedly will have about um, 55 or 56 regions at this moment here. We still don't have that number coming in this place. If I just talk about regions here, these are regions. I'm not going to start counting them. You can see we've got these are regions that are globally established there, and do I kind of comply? No, this is what it is. Now, if you see here in these regions, and on the side you can look at the part. Now, all these regions I want to show you. So all these regions, as you can see here, they have the data centers in them. And in these regions, if you kind of go here and look at the zones, there's a concept of zones that kind of happens to exist. So Azure has more global regions than any other cloud provider, I can tell you. And these regions, they give you the flexibility to scale, and you can bring in your application to users. So let's say if I'm in Singapore, I will never launch a virtual machine that is in the United States. Why? Because my users are in the Singapore. So you have to be able to build that system, build a job around the process. So you have to know that which is the right region, the nearest region around me. So the nearest the region you will choose, the better your application will serve. So for most Azure services, when you deploy a resource in Azure, you will choose the region where you want your resource to be deployed. And Azure has some of the specialized region also. So if I go into the US, and I'll show you, I hope they have it here. Mm-mm-mm. So they don't have the slide, but Azure has a couple of other regions which are specialized regions. One is called as the Azure US DoD region, which is a Department of Defense region. Azure. Yeah, so it's a DoD region. It's one of the regions there that is meant for the government there, and these are physical and logical network isolated instances for Azure for the U.S. government itself. So they have separated a lot of regions for that perspective and do this, and it's possible that a large enough disaster could cause an outage large enough to affect even two data centers. So Azure has an option of creating these region pairs there, and each Azure region is paired with another region within the same geography, like US and Europe or Asia, and they're at least 300 miles away, which together makes a region pair. So I can compare, probably East US and West US as a pair, or maybe Central Canada and Canada East as a pair. So that kind of happens me to isolate resources, and I'm not in a situation where I'm kind of bound. If something goes wrong, my infrastructure goes down there. So whenever it's possible, Azure prefers, if you see there all these regions that we have here, if I kind of combine these options, if we look at these regions, so this distance, you know, or probably this distance, let's say, or maybe this distance in this capacity, Azure prefers that there has to be, or there is a minimum of at least 300 miles of separation between data centers in order to ensure that how they're separated there. And these physical data center separation reduces the likelihood of any natural disaster eventually, and some services are geo-redundant also, which gives you an automatic replication. So if I have a region which is paired, for example, uh, Canada Central versus Canada East, so they are paired regions. So a service which is here is all automatically replicated into this region, and vice versa. So that if this region goes down, the services are up on this region, and you don't have a network issue there. So you have an opportunity to choose the right recruiter. And Azure divides the world into, if you look at this, these are the geographies there that are defined by these geographical boundaries or country borders. So Azure Geography, you can call it more of like a discrete market, typically containing, either minimum of two or more regions there that preserves the data residency and compliance boundaries. And these geographies, they allow the customers with specific data residency and compliance, which are needed to keep their data and up and closure. So geographic is kind of ensure that the data residency and compliance they're all honored there. So you kind of have to do this. So it's again a beautiful part, but we have broken geographies into three part: Americas, Europe, and APAC, which is Asia Pacific and Middle East and Africa. And each region is going to belong to a single geographic only, not more than that. That's going to be an interesting segment, a part of how this works. So if I have to go ahead and show you a simple part of how do we deploy, let's say now I want to deploy a virtual machine. Now, obviously, if I have my, let's say, user in which is near to example West Central US or maybe Central US, where I will deploy the VM, I will deploy the VM into the region that is called as Central US. So the objective of showing you this website is to understand why choosing a region is important. Because if my users are in Central US and I'm deploying, let's say, a resource probably in the North Europe. So what happened there, a user from this has to go all the way to this part to get a response to this. So what are you having? You have a latency in this case. So you want to avoid that. You want to make sure that your users, your VM is in this region and so are your users. So the distance to communicate is less and hence you will have a fast communication. And that's the beauty behind having the region, choosing the right region there.
We're going to take a quick moment and we're going to hear from Sagnik. Sagnik is our vendor marketing manager, and he's going to introduce a couple of promotions and webinar related courses.
Thank you, Leela. So I would like to take this opportunity to quickly take all of our attendees to some of the exclusive offerings and benefits of attending today's event and some of the next steps that are waiting for them in their upskilling journey. So this is the event handout that every single one of the live participants or the attendees today are going to get. So feel free to explore this. You'd find the content section, everything is hyperlinked. You would be greeted with some facts about Netcom Learning as a gold learning partner of Microsoft. We have been a Microsoft Training Partner of the Year. We have serviced 80% of the Fortune 1000 companies. We are heavily involved with training deliveries with respect to the US military bases, and overall you can see that we have a lot of experience and industry credibility when it comes to skilling, and we have some solution for whatever your needs are. If whether you are an individual learner, individual professional looking to just grow your career, or you are an organization, no matter the size, from a 5 or 10 member organization to multi-global organization with thousands and thousands of employees, we have a solution that would meet your skilling needs. All you need to do is get in touch with us and explore the possibilities. It goes without saying, we are there in the industry for over 23 plus years, and we have an authorized training partner status with all the industry leading vendors, starting from Microsoft, of course, but we are also authorized training partners with AWS, Cisco, CompTIA, PMI, Axelos, EC Council, Adobe, Autodesk. You name a vendor, we are qualified to provide you authorized training straight from the vendor, and with respect to your specific focus on your specific objectives, whether as an individual professional or as a business altogether. Now, as part of an exclusive benefit or privilege to all the participants in this webinar, we are providing you with the Learner Portal access for Netcom 365. We highly encourage everyone to please follow the steps. You can click on the link here and follow the steps for activating your account. Your account has been created from the backend, but you still have to activate with using your registered email ID that you used for attending this session. And you can log in through multiple ways. You can set up a password or use your Google or Microsoft or Amazon IDs to access. You'd also find a lot of materials there, including the participation certificates. You'd find the listing of upcoming events that you can participate in. So we highly encourage to go through and explore this learning portal. Now let's quickly take you through some of the latest offers on Microsoft that we have live right now. So the first and the foremost is the Microsoft Skilling Program. It is primarily targeted towards enterprises, and it acts as the one-stop end-to-end upskilling solution. No matter the size of your organization, if you are an enterprise with multiple members in your team, you are eligible to participate in this program. Now, this is driven by Netcom Learning, and we are a Microsoft partner, and that means there are some exclusive benefits that you get to enjoy across the entire Microsoft training portfolio, across Azure, Security, Microsoft 365, Dynamics 365, and Power Platform. Benefits include definitely you get huge exclusive enterprise discounts on your learning plan deployment. We have technology in place that enables you, if you are an organization with employees spread across multiple locations, we're going to make sure that you have the easiest and most convenient enrollment and onboarding process in place. You get both the learner as well as the decision maker access to the Netcom 365 portal that allows you, your management team and your leadership to really monitor and see the progress of individual learners and get some insights into the learner's journey and the overall training progress of your team. And it's a truly 360-degree upskilling program. That means across products, across the entire Microsoft ecosystem, you're going to get your skilling options. Please feel free to connect, get in touch with us. The initial skilling discussion session is free of cost. So without any financial commitment, you can just get in touch with one of our learning advisors and have a very informed conversation about your skilling plans and what would be the best way for you to approach and go forward. As mentioned by our instructor today, as part of the overall offering, you get a link to the official Microsoft ebook on the win-win of certifications. It's a powerhouse of information wherein Microsoft has conducted these multiple surveys across organizations, and you get the perspective on what are the benefits of certifying employees and having the upskilling and participating in this skilling process, both from the employee as well as the employer perspective. So feel free to go through this ebook. The access links are included in these handouts. As you can see, you have to just click on the read free ebook and follow the steps, and you'd be getting access to your ebook for free. Next up, we also have a promotion that is called the Netcom Plus. It is an individual learner subscription, particularly catering to the needs of individual learners. So if you are a learner, or if you are even a company with a specific size of team, and you want to empower each of your team members with a with the capability of pursuing and continuing their individual learning journeys throughout an entire year, Netcom Plus is the go-to solution for that. For just $2,999 per learner per year, for learners less than 10, if you are an enterprise or a team having more than 10 learners, you would be eligible for further discounted pricing. But for $2,999 as a standard price, you get access to more than 350 training classes, including 60 official Microsoft courses, and these are official VILT courses that you get access to. So across vendors, Microsoft, AWS, Cisco, Confia, you get 12 months worth of learning. It is a great solution. We highly encourage you to explore it or schedule a free call to understand more about this offering. We also have a learning passport. This is a great option for enterprises in particular. The Netcom Plus subscription is kind of locked into a specific learner, wherein the learning passport, it gives you and your team, your organization, that flexibility to train multiple employees of of your team, across teams, across your organization, basically across the entire training portfolio of Netcom Learning. So we are talking about 4,000 plus official courses across vendors, valid for 12 months, and it allows you to increase your training fund value by up to 100%. So feel free to get in touch and explore and learn more about the solution if it is the right fit for you. Also, an exclusive offer right now, only valid till the 30th of June 2022. That is the end of this month. We have a security bundle offer going on for Microsoft, wherein you get the official VILT course plus an exam voucher, the certification exam voucher that we all learned about, the value it gets you both as an employee or as an employer, and an additional practice test, official practice test that prepares you to pass that certification exam for the first time. So this entire bundle is available across the entire Microsoft security portfolio, which includes the SC900, 200, 300, 400, the AZ500, and the MS500 courses. Feel free to explore these courses. All the code names of the courses have been hyperlinked. Feel free to go to these pages and explore if it's the right fit. And please pick a schedule that is eligible before the 30th of June to redeem this benefit. As already discussed by our instructor, this slide is a great value for our learners. Please feel free to go through this. The entire learning journey has been mapped here, complete with individual links. So every item here is hyperlinked. All you have to do is just click the one that you want to explore. You'd land on our landing page. You can go through the course outline, take a free assessment if you want to test your skills, if you're already on track for it, if you want to understand, do you need to take the course at all, please feel free to go through the free assessment on the individual course pages and you can continue your journey. Also, look out for our upcoming free master classes. We have two masterclass sessions coming up related to Microsoft, one in July and another one in August. Feel free to register for these events and we hope to see you then. That's all from my end. Back to you, Leela.
We want to thank you all for joining us today. If you do come up with any additional questions, please feel free to send them to us at webinar@netcomlearning.com at any time. And we hope you all found today's webinar to be informative, and we look forward to seeing you back here with us very soon. Also, feel free to tell your friends and colleagues about our webinars and other courses. Once again, thank you, everyone. Thank you, Vishal, and have a wonderful day.